Hey everybody! Today we are going to learn about set and interval notation. Okay, so first I want to talk about interval notation. So interval notation is a really fancy way of writing an inequality. Okay, so it's like another way of writing an inequality. Okay, so now for inequalities, if something is included, we usually put that underline underneath the sign. So this would be less than or equal to, right? For interval notation, we use brackets for that. They look like little boxes. And then if there's no underline, something like this, just less than, meaning that B value would not be included in the interval. It'd be up to B and then stop. We use parentheses for that. Okay, so let's say I have the inequality A is less than or equal to X is less than or equal to B. And we're going to let A and B just be real numbers on the number line. Okay, now if this were the case, right, I would put a closed circle on A and a closed circle on B, and I would shade everything in between A and B. The way you write that with interval notation is I would put a bracket next to A, comma, and then a bracket next to B, saying everything between A and B, including the value of A and the value of B. Now, let's say what would happen if I wanted every number between A and B, but not exactly A and B. So A is less than X is less than B. That's saying that I want all the numbers between A and B, but do not include A and do not include B, meaning open circle on those. So what I would do is I'd use parentheses, and I would say that would be parentheses A and then parentheses B, meaning all the numbers between A and B except for A and B. So get really close to A, but don't use it. Get really close to B, but don't use it. All right. Now, what's great about this is you can kind of put them together. So like, let's say A is included, but B is excluded. Well, that's cool because I can still use all the numbers between that. I want to include A, so that would be a closed circle. I want to exclude B, so that would be an open circle. And I'm looking for the numbers between that. So I'd say including A, but not including B. So I'd have a bracket for A, comma, parentheses for B. And that could be the other way around as well. So you could say, I don't want to include A, but I do want to include B. So I would do an open circle for A, a closed circle for B, and I would shade everything in between. Now, these types of intervals are what we refer to as bounded intervals. They are bounded. This is something bounded between A and B. Now, A might be inclusive or exclusive, but the interval is bounded by two values. It's possible for an interval to be what is referred to as unbounded, meaning it approaches infinity either to the right or to the left. So let's look at what an unbounded interval would be. So something like X is greater than or equal to A. Now, it could include A, so I want a closed circle on A, but then I want to say it's everything possibly greater than A. So that actually goes all the way out to this arrow and then off to the right of infinity. So I want to include A, so I'll put a bracket for A, and then I want to say I'm going to the right being the positive direction forever. So I'm going to say that's positive infinity, and then I'm going to put a parenthesis. I'm putting a parenthesis because infinity can't be included. Infinity is infinite. But I can approach infinity, and I'm going to continue to approach infinity for the rest of my life using said arrow here. Right? Now, that's what happens, when we're going this direction. Now, you don't have to include A. So let's say you want X is greater than A, meaning all numbers greater than A, but not A itself. Right? So in that case, you would exclude A and then go towards positive infinity. Remember, this side is positive, this side is negative. In math, the right is positive, the left is negative. So I would say A not included, excluded A to positive infinity. Remember, always put parentheses on infinity. You can't include infinity. Infinity is a concept, not a number, so you can't include it. All right? Now, What if I want to go to the left? So look here, I have x is less than or equal to a. All right, so I'm saying a is included, but I want all the values less than a. Well, I need to tell my audience that I'm still using infinity, but I'm using infinity to the left, not infinity to the right, infinity to the left. Here's how I'm going to do that. I'm going to include a, which means I'm going to use a bracket for a, and then I'm going to go negative in infinity because this is the negative direction on the number line. So I'm saying go infinity to the left or the less side. X is less than or equal to a. The same thing could happen with exclusion. So let's say I want everything less than a, but not including a, meaning there's no bar here. So again, I want a, I want to start at a, but not include a. And then I want to go less than for all of infinity. I would say parentheses a and then negative infinity, meaning infinity to the left or where the numbers become less. These are called unbounded. The reason they're unbounded is this infinity right here. You can't bound infinity. Okay, let's do some practice with this. Okay, so let's write these in interval notation. Okay, so let's write this in interval notation. So I have -2 to 3. So -2 is less than or equal to x is less than or equal to 3. And I want to include 2 and 3. So I want the interval -2 to 3, and I want to be sure to include -2 and +3. So I gave them brackets. Example 2. So I have x is greater than -1. Okay, so I have a -1. I don't want to include -1. Okay, but then I want everything greater. Greater is going to go to the right, and the right is positive. So I'm going to use the infinity sign. You can do this directly from a number line as well. So looking at this number line, I can see that I'm using -3 to 4. I want to include -3 and exclude 4. So I'm going to put a bracket with -3, and then I'm going to go to 4. Over here is going to be a parenthesis. Notice, guys, that my intervals are always listed least to greatest. -2 is less than 3. -1 is less than infinity. -3 is less than 4. Like, it's always least to greatest in the interval. Okay? This one would be unbounded. Notice that it goes down to infinity, and I'm covering negative infinity. So I start way over in negative infinity. Infinity always has a parenthesis. I'm going to come all the way to 3, and I want to make sure that 3 is included. Now, there's another type of notation we use for intervals. Sometimes it's called set builder notation. Sometimes it's just called set notation. I grew up calling it set notation. I've seen it also referred to in some manuscripts as set builder notation. You use the words you use. Now, this is it right here. What it is it'll have that inequality symbol that you're used to seeing. It'll just have this weird stuff kind of in the front. Notice it has braces. That's because it's a set. Sets have these like braces here on the end. These are called braces, right? Okay, bracket, parenthesis, brace. Okay, that's how we name them in the United States. Now, if you're watching a British YouTube, they'll name it something else. All right, so the way you read this, okay, is this little X in the front? You would say the set of all real numbers X. So they're telling you we're going to use real numbers. Real numbers are represented by X. Such that, this straight bar is the words such that X is less than or equal to A or X is greater than B. This is actually super duper handy because sometimes our intervals don't intersect. So for instance, X is less than or equal to A. That would include A, so I would have a solid circle on A, but then I'd go less than forever. X is greater than B. So excluding B, I want to be greater. This is super handy for times that you're including two intervals, so two sections of numbers for one solution. That's great. Notice all of these, they intersected. Yes, there was only one shaded portion in the number line. This is super handy for when there's two shaded portions in the number line with a gap in the middle. Okay. Let's look at this one. Let's read this together. So right here, I just have an X. So it'd be the set of all real numbers X such that X cannot equal A. Well, let's talk about what that would look like. We cannot equal A. So I want to exclude A. In order to exclude A, I put an open circle on it, exclude A. And then I want every other number. Cool. See, look, every number is included except A. Any number in all the universe is good for a solution, just not A. Again, I'm using set notation, great, or set builder notation, as you might say. Really handy for when I have two sections of my number line that are shaded, but there's a portion in the middle that's not being used. Okay, so let's look at these examples, and we're going to take these examples, and then we're going to graph them. Okay, so we're going to make the graph for each of these. I'm going to go purple on this one. Okay, so X, the set of all real numbers X, such that 2 is less than or equal to X is less than or equal to 5. Okay, so it looks like X is between 2 and 5. So I have a number line. 2 should be to the left of 5. And it looks like 2 and 5 are included. And then I want all the numbers in between. So example 6. I like to just say X such that. We only know what real numbers are, so I'm going to assume every time I give you that X, it's a real number, okay? So X such that X is less than or equal to 0, or X is greater than 4. So there should be a number line, and there should be a 0 and a 4 on it. 0 should be to the left, 4 should be to the right. Now we want 0 included, notice that underline, and we want 4 excluded. Okay, great. Now let's see where to shade. X is less than or equal to 0. So less than 0. And then X is greater than 4. Okay. Here, they'd like us to write using set notation. So to give some information, we're going to write this using set notation. Set notation has a brace. And we're going to use X to represent all real numbers that are possible, and the such that line. Yes. So all real numbers, that's X, such that. The set of all real numbers greater than 5. So I need all those real numbers to be greater than 5. And don't forget to close your brace. What is open shall be closed. Thus saith your math teacher. Oh, now this is a fun one. This one is fun. So you can take something that's actually interval notation and you can change it to set notation. So we're going to use all real numbers. So I'm going to go ahead and put my X such that line because I'm going to use X to represent all the real numbers that are possible. And this set goes from negative infinity to negative 1. So that would be less than negative 1. So X has to be everything less than negative 1. I'm not going to underline this, okay, because negative 1 is not included. Notice it is excluded, right? So if I were to do this on a number line, right, I'd have negative 1 with an open circle, and I would have shaded this way, right? Or, and then I have this interval here. This interval here would have been negative 1, open circle shaded to the positive, right? Negative 1 to positive infinity. So X is greater than negative 1. Right? So you could have written it like this. There's actually another way. This is absolutely correct. There's another way you could have written this. Notice that negative 1 is the only excluded number. Do you see how I'm using everything less than negative 1 and everything greater than negative 1? So I could say X such that X does not equal negative 1. Either one of, excuse me, I'm so sorry. Either one of these would be, either one of these appropriate answers. So thanks so much, you guys.